Hi everyone, in this video I want to continue working on the unit circle. This time I want to look at not necessarily tying back to a t-value, but more looking at if you know a point is on the unit circle, you should be able to find all the values of all the trig functions without needing to know the t-value. So I give you a point, 2/3 root 5 over 3. And the very first question is, do we actually know that that point is on the unit circle? So I think the easiest way to establish that is to remember that we know the relationship between x and y for points that are on the unit circle. If you're on the unit circle, you are exactly 1 unit from the origin, which means you should satisfy the Pythagorean x squared plus y squared equals 1. So we can check this. We can say, okay, well, our x is 2/3 and our y is root 5 over 3. And this is a question mark. Does that in fact equal 1? So I'm seeing 4/9 plus 5/9. And yes, that does in fact equal 1. So yes, the point is on the unit circle. As soon as I know that, I again should be able to give the values of all of the trig functions without having to know the t that ends there. So let's just use variable t to be the one that lands us at this point, 2/3 root 5 over 3. So let me think about this. 2/3 root 5 over 3. We are in quadrant 1 since both are positive. And root 5 over 3 is a little bigger than 2 over 3, since root 5 is a little bigger than 2, which means we're above the y equals x cutoff. Our y is a little bigger than x, so we're going to be somewhere a little up here. Okay, so if we want to know the value of sine t, cosine t, tangent t, cotangent t, secant of t, and cosecant of t. Again, this is really just memorization work. So this section in particular is heavy on memorization, and that's going to be your very biggest job for the stretch heading up into the exam, is to make sure that you have all of these definitions of the trig functions and relationships between the trig functions memorized. And we'll shortly hit special values, and you want to make sure that you have mastered and memorized those as well. Okay, so for our point, 2/3 root 5 over 3, sine t is supposed to tell me the y coordinate of my point. So sine t is going to be a root 5 over 3. Cosine t is supposed to tell me about my x coordinate. I know my x coordinate is 2/3. Tangent gets a little bit messier. Tangent t, I'm going to show some work down below, is a sine over cosine. So root 5 over 3 divided by 2 over 3. You'll have to do a fair amount of fractions work in this class, fractions and radicals we work with constantly, as you'll start to see very quickly. So if we want to divide by a fraction, what we really need to do is multiply by the reciprocal. And it looks like those 3's are going to cancel, and tangent will be a root 5 over 2. And remember, if you want a little bit more of a geometric interpretation of tangent, tangent tells you the slope of the line that goes through the origin and your point P, or whatever you're calling your point. I think it is P in this one. Okay, so cotangent is the sine over cosine, so we could do similar work, or we could remember that cotangent, as long as we don't get any weird domain problems, is just the reciprocal of tangent, and say this is a 2 over root 5. Okay, so I want to point something out here with the radical work. I don't really care if you rationalize denominators or not. I don't think that, so let's see, I'll show you how to do it and then we'll talk about it. I think you should know how to rationalize denominators, but I don't care if you actually do that step for this kind of a problem. So you want to be really competent when it comes to eliminating square roots or getting square roots out of places you don't like them. So in this case, what we do is if we want to get rid of the square root in the bottom, it's tempting to just square it, but that changes the value. It's no longer equal to 2 over root 5. So instead what we do is we cleverly multiply by 1, and on the top we get a 2 root 5, squashing in here. And on the bottom we get root 25, which is 5. So I think that work is really important. You should be able to do that. But again, what we need it for is not actually rationalizing denominators. We saw it in function review. What we really want to be able to do more often is rationalize numerators, and we will have reasons for wanting to get rid of radicals in the top or the bottom when we're doing some calculus. So you should be very good at manipulating radicals, but I don't think that 2 root 5 over 5 is any better than 2 over root 5 for your answer to this question. Okay, enough of a sidetrack on that one. Secant. Secant is 1 over cosine. And remember, 1 over, that just means reciprocal. That's what reciprocal says. So if you want 1 over 2/3, you're going to get 3/2. Or if you want to think about a little bit of work there, if we want 1 over 2/3, once again, we have to multiply by the reciprocal. So we get 1 times 3/2, which is 3/2. And similarly for cosecant, cosecant is the reciprocal of sine. So it should just be 3 over root 5. Okay, so given a point, you should be able to tell me the values of all of the trig functions. Given an arc length, you should be able to tell me how to get my x and y coordinates. And if it's a particularly nice t-value that lands you at a quadrant, you should be able to give me even better answers that don't involve sine or cosine, but just exactly what the value of x and y and any of the other trig functions are. Okay. One more in this one. Number 7. If sine w is equal to 5/6 and w ends in quadrant 2, find the values of the other 5 trig functions of w. Okay, so we're on the unit circle. We know that sine is equal to 5/6. Sine is your y value, so we're fairly close to the top of the circle. 5/6 is just a little less than 1. There are 2 possibilities. If our y value is 5/6, we could be in quadrant 1 or quadrant 2. So this information is really important. Otherwise, we're not going to know exactly what the value of the trig functions are. We'll be potentially off by plus or minus. So we want this point, the point in quadrant 2 that has a y coordinate of 5/6. Okay, so one of them we've got for free. Oh, I guess I did just say 5, but we'll write it down. So we know that sine w is 5/6. It would be really nice to know cosine of w, and then the others should be very easy after that. So this, again, you want to make sure you don't forget. This is not too painful at all, but people will space how to figure this out. So how do you get your x coordinate given your y coordinate? And remember, the relationship between x and y is that x squared plus y squared always equals 1. And you can do that with, you can write the sine cosine version if you'd like. Sine squared plus cosine squared always equals 1. So here we get x squared plus 5/6 squared is 25/36. Again, you're going to do a ton of this really similar fraction work and Pythagorean theorem work. So if you get efficient and you can skip a couple of steps, that's fine with me. Okay, and then we need to subtract 25/36 from both sides. So remember that 1 is 36/36. So if we subtract 25, we're getting 11/36 is equal to x squared, which means that our x is plus or minus root 11 over 36. I don't care about all simplification of radicals, but I do care about bothering to take the square root of perfect squares. So you should definitely take the step where you say, oh, well, I know the square root of 36 is 6, so I can just say that's root 11 over 6. And you want to be careful with that. The rule is you can split radical square roots up over fraction bars, over division. and over multiplication, but you cannot split them up over addition. So if you had the square root of 11 plus 36, you wouldn't say that's the same as the square root of 11 plus just a plain old 6. That doesn't work, but for multiplication division, it does. We can even do a little better than this. This is why we had the information about quadrant. We know we're in quadrant 2, so we know we want the negative x value. So this is just telling us if you say your y is 5, 6, there are 2 possible x's, we already know which one we want. So cosine is negative root 11 over 6. And once you've got sine and cosine, the others should be fairly easy if you've got your definitions memorized. Tangent is sine over cosine. So we are dividing fractions, we'll multiply by the reciprocal, the 6's cancel. I hope after not too long you've done enough of these that you get really good at quickly zipping through some of that fractions work. So a negative 5 over root 11. And once again, I don't care if you rationalize the denominator. If you think you're not good at it at all, run through it a few times before it becomes really easy. Until it becomes really easy. Here you'd multiply top and bottom by root 11, so you'd have a negative 5 root 11 over 11. Cotangent is the reciprocal of tangent, which means it will be negative 11 over root, I keep saying it backwards, negative root 11 over 5. Secant is the reciprocal of cosine, which means it's negative 6 over root 11. And last but not least, cosecant is 1 over sine, which means, oh, my pen is so tired. It's 6 over 5. Can you read that? Just barely. Okay, 6 over 5. So there was one other thing I was going to say. Oh, yes. So I've gotten in the habit of writing the parentheses around the variable as much as possible, but I caught myself here that I wasn't doing it. And I just like to point out that you don't have to do that. If I just write cosine w, the fact that the w is the input of the cosine should be implied. But I find that people get some confusion about the functions, about what's actually inside and what's not inside. So I've started trying to use the parentheses a lot. So it is legal to just say sine theta without parentheses. And I have no problem with it. I'm just trying to be in the habit of writing them. All right, thanks for watching.